All right, welcome to The Explainer. Today we're diving into a tool that's really making waves in tech circles, especially with engineers. It's called n8n. We're going to unpack exactly why it's earning this reputation as the engineer's automation engine.
So to kick things off, let's start with a question that, if you're a machine learning engineer, you've definitely asked yourself this. Why is machine learning so much more than just building the model?
Well, it's because the model itself, that's just the shiny part, right? It's the tip of the iceberg. The real work, the deep engineering challenge, it's all happening underneath in what we call MLOps. We're talking about wrangling these messy data pipelines, trying to connect a dozen different APIs, and of course, setting up constant monitoring so the whole thing doesn't just fall over.
And that brings us squarely to the big challenge in modern MLOps. A lot of the automation tools out there, they're either way too simple for the complex stuff we need to do, or they're super rigid, basically locking you inside a black box where you have no control. So yeah, when we say MLOps, this is what we mean. It's this whole ecosystem. It's the connective tissue, the glue that holds a real machine learning application together once it's out in the wild. And it's precisely this complex, sometimes messy environment that n8n was built to tame.
And this is why we really need to shift our thinking. We shouldn't see n8n as just another tool on the pile. It's different. It's a whole new kind of framework, built from the ground up, for technical people, by technical people.
So, what's the big deal? Why are engineers getting so excited about it? Well, first off, self-hosting. That means you have absolute control over your data and your compute. Huge. Then there's code extensibility. You can just drop in your own custom Python or JavaScript whenever you need to. It's also got a native AI stack, which means you can build some seriously complex, multi-step AI agents right inside of it. And maybe best of all, it's source available. It's not a black box. You can pop the hood and see exactly how it works, which, for an engineer, is everything.
Okay, so to really get a handle on a tool this powerful, you've got to understand how it's built. You have to know its architecture. So let's pull back the curtain and take a look at the n8n blueprint.
It's actually brilliantly simple when you break it down. Think of it like a three-step process. First, you've got the editor. That's the visual interface where you drag and drop nodes to build your workflow. What it's really doing is creating a JSON file that's like a blueprint. Step 2, that blueprint goes to the engine. This is a back-end service that just reads the JSON plan and executes it, one step at a time. And finally, step 3, you have the database. This is where everything gets stored. Your workflow definitions, your credentials, all your execution logs. You'll probably want something solid like Postgres for this.
Okay, lean in for this one. If you only remember one thing from this entire explainer, make it this. The source material flat out calls this the single most important concept in n8n, the idea that all data is always passed as an array of objects. Seriously, getting this one concept is the key that unlocks everything else.
So what does that actually mean? Well, each object in that array is what n8n calls an item. You can think of it as one unit of work. And inside every single item, your actual data, the good stuff, lives inside a key called JSON. That's it. This consistency, this predictable structure is what makes n8n so incredibly reliable to work with.
All right, now for the really fun part. We've got the fundamentals down. Let's start talking about what the source material calls the engineer superpowers. These are the features that let you go from simple automations to building truly custom, production-grade solutions.
The whole philosophy here is about giving you the best of both worlds. You're never stuck. For most things, the built-in nodes are perfect. They're fast, super readable, and a breeze to maintain. But the second you hit a wall or need to do something really custom, you just switch over to the code node. That gives you unlimited logic, maximum performance, whatever you need. You always have the right tool for the job.
And for anyone in machine learning, this is a total game changer. You can literally just flip a switch on the code node and turn it into a Python environment. That means you can import and use all the libraries you already know and love. Pandas, NumPy, scikit-learn, you name it. You can do complex data wrangling and analysis right there, inside your workflow. It perfectly bridges that gap between data science and automation.
And n8n also does this incredible job of making really advanced AI concepts, like Retrieval-Augmented Generation, or RAG, feel super accessible. It breaks it down into simple steps. Step 1, you ingest your docs, load up your private knowledge base. 2, you create embeddings, basically turning all that text into numbers that a machine can understand. 3, you retrieve the relevant facts based on a user's question. And finally, step 4. You feed those facts to a large language model along with the prompt. The result? A much more accurate fact-based answer.
Okay, so this naturally leads to a really cool question. Once you've built an AI agent inside n8n, what can it actually do? What are its capabilities? Well, the answer is all about its tools.
And here is where it gets mind-blowing. Any n8n node can become a tool in your AI agent's toolbox. You want it to be able to search the web? Just give it the HTTP request node as a tool. Need it to update your CRM? Hand it the Salesforce node. You can even give it the execute workflow node, which means your agent can trigger other complex automations you've built. Its potential is, well, it's literally limitless. It's only limited by what you can build in n8n.
So you see, with these kinds of powerful features, we have to start shifting our whole perspective. We're not just building little one-off automations anymore. These are evolving. They're becoming full-blown, reliable, production-grade applications.
So how do you scale something like this for the real world? You've basically got two paths. There's vertical scaling. That's the simple way. Just get a bigger server, throw more CPU and RAM at it. But for true high-throughput production workloads, you'll want to go with horizontal scaling. And n8n has something called queue mode for that, where you can distribute the work across a whole fleet of smaller worker servers.
And that's the crucial thing to understand here. Queue mode transforms n8n into a genuine distributed system. You have a main process that acts like a traffic cop, adding jobs to a message queue, usually Redis. Then you have multiple worker processors that are constantly grabbing those jobs and executing them in parallel. This is how you get high availability and handle just massive workloads. And this isn't just a hack. It's all supported by the kind of enterprise-grade features you demand from any serious production service. You can stick it behind a reverse proxy like Nginx for security. You can integrate with secrets managers like HashiCorp Vault. You can even manage your workflows as JSON files in Git for a full GitOps approach. You can even prune old execution data to keep the whole system lean and mean. There's this quote from the source material that just perfectly captures this whole journey. The goal is to transform your perception of n8n from a mere automation tool into a comprehensive framework for orchestrating complex data flows. And that's exactly what we've seen. We started with a simple tool, and we've ended up with a complete framework for building the complex data systems that run modern AI and machine learning.
So I'll just leave you with this final thought. When your automations become this powerful, this scalable, and this intelligent, when they stop being just automations and truly become applications, what will you build?
Swamped answering the same questions from employee over and over again. Questions like, how does the vacation process work? What company benefits do we have? And where can I find the policy on remote work? This takes up a lot of time and prevents the HR team from focusing on what actually matters, like working with employees one-on-one on helping them on their career path. Now, here's the thing. Most of these answers already exist in the company manual. But the problem is, that manual is spread across multiple documents, each multiple pages long. So the HR manager heard about AI and wonders, can AI help us here? And guess what? It can. So the goal of this course is to build a simple internal chatbot that can answer common employee questions about company policies. So your HR team can focus on real HR work instead of answering the same things over and over again. You'll find all the materials you need for this course in the accompanying GitHub repository. So let's open up n8n and get started. Add the actual AI node over here. There are a couple of options in n8n. For our purposes, we are choosing the AI agent node, which allows us to flexibly evolve our simple chatbot as we go. So let's select AI agent and make sure it's connected to the chat trigger node. For now, let's close this and make sure that we also connect a chat model here. This is the actual AI service. So click plus and you see there are various options you can choose from. I'm choosing Google Gemini here. Why? Well, because it's pretty easy to set up. If you haven't connected Gemini to n8n before, just simply click this Create New Credential menu over here, and then you need to insert an API key. Where do you get this API key from? Well, just visit aistudio.google.com and you will see that there's a button saying Get API Key. And the nice thing about Google Gemini is that you get a pretty generous free tier. So that means you don't need to put in a credit card. You can just go ahead and create an API key, which gives you a couple of thousand tokens every day to work with. So click Create API Key, and you might see this little window over here or not. If this is an account which is connected to Google Cloud. If not, you will just directly see the API key instead. But in the end, you should see something like this. So let's copy the key, go back to n8n, and insert the API key over here, hit save, and you're all set. Okay, so now you have a list of models to choose from. And one of the most powerful models right now is Gemini 2.5. So let's go ahead and search that by putting it in here. You can use the Flash version, which is faster and a little cheaper, or Pro. Let's use the Pro version for now, but it's also a little slower. You can try out different models as you like. Now let's close this one for now. And this is actually the only thing we need to set up in order to make our chatbot work. So let's try it out. You see this chat window over here. And in this chat window, you can interact with your agent or with your chatbot immediately. So far, it's not really an agent because it can't do anything, but it's a simple chatbot. So let's say, hi. And we see the response here. Hello, how can I help you today? Again, you might get a different response, but the essence here is that our chatbot configuration is working. Let's ask it a different question, like, for example, what's your name? You see, it doesn't have a name, but there's one more thing I wanted to show you here. So let's say we give this model some instruction or something to remember. So I could say, for example, remember the number 2. It will probably come back to me and say, yes, of course, like I remembered that number. Now let's ask it, which number did you remember? So you can see that the chat here, that the AI here has no idea what I'm talking about. So what happened, even though in this little interface, everything looks like a single chat, what happens under the hood actually is that we make separate API calls to the model. So the model has no idea what I mentioned 1, 2, or 3 messages before that. In order to make this possible, we will need to give our chatbot a memory. And this is exactly what we will do in one of the next videos. We will give our chatbot a personality to make it actually helpful and help us to ask questions and also remember what is being said in one conversation. So with that said, I'm looking forward to seeing you in the next video. Use case. Before we talk about the solutions, let's address the 2 big limitations that language models face out of the box. First, there's the knowledge cutoff. Language models only know things they were trained on. Second, they have, luckily, no access to your internal data. So they don't know about your company documents, databases, or Slack threads. If your use case needs that information, you need a way to bridge that gap. And that's what we will explore in a bit. But first, let's start with the knowledge cutoff problem. LLMs are trained on a fixed dataset, and that dataset has a cutoff date. You can see it here in this example. We ask, what happened in March 2025? And the model replies with something like, I don't have that information. This means that even state-of-the-art models are generally out of date the moment they are deployed. To make this concrete, here's a look at some examples. Here's a list of Google's Gemini's models and their knowledge cutoff dates. You can see that Gemini 1.5 Pro only knows about things up to May 2024. And even their latest 2.5 models lag a few months behind by the time they were released in mid-2025. Which makes sense because building and deploying these AI models takes time. OpenAI is no different. Even their most recent models have a cutoff date that is often more than 12 months ago. The reason I'm showing you this here is that besides internal information, you also want to consider whether you need recent information for your given use case, because an out-of-the-box LLM might not have it. The second big challenge is internal data access. Out-of-the-box LLMs, hopefully, have never seen your organization's private information, unless there was a big data breach. That means they don't know your proprietary language, knowledge, or documents. If you ask a model about something specific to your business, like a product spec, best case, it won't know. Worst case, it will just make something up. So how do we actually solve these problems? There are 2 main ways to give LLMs access to your data: fine-tuning and context augmentation, also known as prompting. We'll explore both in more detail, starting with fine-tuning. Fine-tuning means taking a pre-trained LLM like GPT or Gemini and continue training it on your own proprietary data, typically in the form of question-answer pairs or examples with labels. The result is a custom model that internalizes your data and performs better for certain use cases. But as we'll see, that comes with a trade-off. One of the benefits of fine-tuning is that you get a deep integration of your data into the model itself. That means it can develop domain-specific expertise and often perform better on niche or specialized tasks where general models tend to fall short. But it's not without trade-offs. Fine-tuning is generally rather expensive and technically complex. If you consider the data, infrastructure, and skills required for it, it's considered rather slow, since you also need time to implement and retrain things as they change. And one of the biggest drawbacks, especially for integrating hard facts, even a fine-tuned model still has a cutoff date, just a more recent one. Plus, there's no guarantee that it will actually improve performance. You have to measure and observe that carefully. So when should you use fine-tuning? You can use it to change the behavior of the model, for example, making it answer questions directly instead of asking follow-ups. You can also tune it to match a specific style, like your brand's voice or tone, and it's especially useful for narrow tasks like classification, tagging, or form filling, where consistency and precision are key. Fine-tuning can also help to improve general language performance in underrepresented domains, or train the model to write code in a specific programming language with better accuracy. In these cases, fine-tuning is absolutely worth considering. Now let's talk about the second approach, context augmentation, also known as prompting. Instead of changing the model, we keep it exactly as it is and simply feed it the right context at runtime. That means crafting a prompt that includes the model's role, its goal, the task at hand, any formatting rules, and most importantly, the knowledge it needs to generate a good response. This additional information can come from documents, databases, or tools, whatever is relevant to the question. This approach is simple, flexible, and works with any off-the-shelf LLM. All the magic here happens in the prompt. Here's an example. On the left, we build a structured prompt. We define the model's role as an internal HR advisor, clarify the goal, specify the task, formatting details, and include the actual HR policy document as the knowledge source here, with our company policy. No fine-tuning required, just smart use of context. Context augmentation comes with a lot of practical benefits. It's simple and immediate. You don't need to retrain anything. You can get started without any particular technical setup, as long as you can concatenate a text string, and it works with any LLM, whether you're using OpenAI, Google, or a local model. But there are some trade-offs. You're limited to the model's context window, which caps how much information you can include. It can also get pretty expensive or slow if you're stuffing in large chunks of text repeatedly. And sometimes longer prompts lead to less predictable responses, depending on how the model processes context. So while it's easy to use, there are some natural limits to this approach, especially if you push it to the context limit. In our example today, we'll rely on context augmentation to build the HR chatbot. So let's get started and see how this looks like in practice. And one of the most straightforward ways is just to provide that information in a prompt. So let's go back to our GitHub repository and select Simple Chatbot. In there, you will find a system prompt. And this system prompt is really pretty straightforward. It defines a role, in this case, an HR assistant that is here to answer common questions based on the FAQ below, and the FAQ is below here in source data. So all of that information is stored here in this system prompt. Also, there's a persona. We are a dedicated HR support assistant. It can't take any other persona and should not try to do anything else than that. And there are some constraints here which you can read by yourself. This is just to help the model stay more in line with the current character of being an internal HR support assistant. The fallback response whenever the model does not know anything should be, I'm sorry, I can't answer that, please contact HR, which is super important because that helps us to mitigate hallucinations, and every time there isn't really a clear answer to a question, the chatbot can just respond with, I'm sorry, I can't answer that. So now let's copy this entire prompt and go back to our chat workflow. Open the AI agent node and click Add Options. Click System Message, and in here, replace the existing system message, "You are a helpful assistant," with the system prompt that I just provided. Now, this system message alone will give the chatbot the character and also the information to be useful, actually, right out of the box. So let's try this out. Let's clear the execution history from below, restart the chat session, and greet this bot with something like, "Hi." As you see, it comes back to us and says, "I'm an HR support assistant. How can I help you today?" And I could ask about something that is now stored inside the FAQ. Like, for example, what company is this? And it will come back and say, it's the assistant for ABC Inc. I could also ask more specific questions, like, for example, what's the vacation day policy? And it will give me that information based on the FAQ data in the prompt. Now, what happens if we ask it about something that it can't answer? Like, for example, my cat is sick. What should I do? And as designed, it's saying, "I'm sorry, I can't answer that. Please contact HR." Now, this is actually quite good out of the box, but there's still one core component missing. Because right now, the chatbot, even though it appears like that, still does not have any memory built in. What do I mean with that? For example, if I ask it about, what did I just ask? It won't be able to answer this information because it doesn't have any history of the chat. Even though you can see the chat here as one single history, the model itself only gets one prompt and generates one answer. You can see that here from the traces in the execution log. So you see, this is actually what happens. This was the input, our system prompt, and then at the end of this system prompt, all the FAQ data included, everything that we just provided. There was also a question from the human, what did I just ask? But there isn't any context on the previous message history. It's literally just the system prompt plus the single user message that it just got. So this chat right now has no idea about what happened before in the conversation. And of course, that isn't really useful because we want it to keep track of the conversation so we can ask follow-up questions or dive deeper into specific topics that the chatbot is offering us. So let's do that in the next video. The simple memory will allow you to just keep track of a number of previous messages inside one chat. If you want to store those chats to a database or have like a chat archive or so, there are other options to do that. For now, let's keep it simple. And let's, for example, say that our bot should be able to retain the last two messages in our conversation. So let's click that and let's try it out. So for example, let's ask our bot something like, what are employee benefits? And you can see it lists those different benefits here. And now I can say, tell me more about the first. This is now providing us an answer, especially about the first item of this list. And you can see it refers back to the health insurance benefits that our company is offering. And you can see that this is exactly this bullet point over here. And this is just possible because it was able to remember this interaction thanks to the memory. Now let's try one more and say, tell me more about the second. And great, you can see it's referring back to the 401k plan as mentioned here in this list. Now what happens if we ask it about the third? You can see that it comes back to us with the answer, ABC provides mental health support through access to EAP services, therapy, and wellness. Now, this sounds like a good answer, but if we actually go back to the original list, we can see that number 3 wasn't about mental health support, but instead about paid time off. What happened is that it took up this third piece of information from the original prompt and not from the list that it gave before. Why? Because we just kept the last 2 messages in our memory. And you can actually inspect the memory over here. So you can see all the input that is being stored right now in the memory. And if you go through that, you will see that the original list, the one that it outputted here, is not stored in the memory anymore. And this is just a quick demo to tell you or to show you that in this case, the length of the context memory that we give to the bot really defines how much the bot can actually look back into the previous conversation log. This has nothing to do with what's being shown in the user front end. You can show a chat that is forever long in the user front end, but this memory parameter here will define how long the bot will actually be able to look back and essentially just keep that information as part of its context window. So I typically adjust this to a value like 10, 15, maybe 20 messages, because if it's too long, especially if you have very long system prompts, or if you augment the system prompt with other information, like for example from a RAG architecture, the context window can get pretty long, especially when you have messages that the bot generates, which are also pretty long in return. So choose a value here that fits your needs, and also make sure that the user interface also accommodates for that, because if the bot can only remember the last 5 interactions, but the user sees like the last 50 chat messages on one screen, there might be a different expectation of what the bot can still remember and what not. So, but with all that implemented, we now actually have our first working version of our bot ready. So with that in mind, let's go ahead and actually make this bot public so we can interact with this chatbot not only inside n8n, but also through a web interface. So let's do that in the next video. But through a simple web interface. In n8n, currently there are 2 modes: the hosted node, which hosts your chat on a page provided by n8n, or the embedded chat. The embedded chat allows you to integrate your chatbot as a widget on, for example, your very own website. Let's take the hosted chat for now. We can select which kind of authentication we like, whether we want to have basic authentication, like for example with simple credentials, or with an integration to OAuth, for example, or whether we want to use the authentication by n8n or simply no authentication at all, which is what I'm choosing today. Now, the initial messages here are a bit tricky because we can, of course, define like initial greeting message. In this case, the standard, "Hi there, my name is Nathan. How can I assist you today?" But bear in mind that this is just really shown on the front end. The bot itself has no idea about these initial messages. So for example, if the first question to the bot is, "What is your name?" it doesn't have any idea about this name because this is really just shown in the front end. Now, there are also some options you can explore. For example, you can select whether you want to allow file uploads, or whether you want to load a previous session, or you can customize the title, the subtitle, or the chat styling. For now, let's go back and let's not choose the styling for now. Let's just close this one. Make sure that your chat is active so you can actually access this chat online, and then open the chat node, copy the URL, and open this URL in a new browser window. And here you are. Here's your chatbot. So let's give it a question or say something like, "Hi," and let's see what it comes back with. As you can see, it takes a while for us to get back here. And why is that the case? Well, because we use a pretty large model. Gemini 2.5 is a pretty heavy large language model. If we want to have faster responses, one of the easiest ways is just to go back and actually customize our model to something that is just responding faster. So let's do this right now. Let's go back to n8n, close this one, and open our Gemini chat model. And let's just switch off Gemini 2.5 Pro with 2.5 Flash, which is much faster. So let's choose 2.5 Flash and also adjust some options here. One of the most common options that you want to tune is the sampling temperature. By default, it's 0.4, which is quite high to be honest. So let's tune that down to 0 to make our answers by the chatbot more consistent and quote unquote less creative. So what we can do as well is if we go to our chat message node here to customize the appearance. For example, we can change the title. Instead of saying something like "Hi there," we can say HR support chatbot, and as a subtitle, maybe we could say something like, ask any question about our company. And of course, there are some basic styling options in here. If you open them, you can see that you're able to adjust colors and fonts depending on your preference to make the chatbot look a little bit more like a way that you would like it. So let's close this for now and go back and actually copy our chat URL. First, make sure that we save this workflow and actually make sure this is executed once. So let's close that so it's not cached anymore in our browser. Copy this chat URL again. The chat URL is always the same, even if you style it. So the URL will always be the same. So let's open this URL now. And as you can see, it now says HR support chatbot and ask any question about our company. And now if we give it a very simple prompt or trigger like, hi, thanks to Gemini 2 Flash, it should be much faster. And there you go. So if we ask it now something about how many vacation days do I have, it will come back to us with the answer much faster. So this is how you can trade off performance versus speed if you like. Going forward, I will use Gemini 2.5 Pro because it just has like higher context window and also better to follow instructions and process large amounts of information. But of course, at some point that takes a little time to come back to you. If you want a model that is really fast and snappy, go with Gemini 2.0 Flash or any other model that you prefer from any other provider. In n8n, it's really easy to switch them out. So feel free to try it out, ask it a couple of questions and see how it responds. Try to push it into areas where it should not respond back to you. For example, if we ask it something like, how is my cat? It should come back and say, well, I can't answer that. Please contact HR. But if you ask it about something like, where do I get a new laptop? Let's see if this was in the FAQ section. I hope so. Then you should see that this is the answer here. So you see, this is how you can actually implement a really straightforward, easy to set up HR support chatbot inside n8n. And of course, you can tailor that to any other scenario that you have. LLMs essentially work with the context we provide in a prompt. Alongside the usual elements like the model's role, its goal, the specific task, and any formatting instructions, we can also inject additional information directly into the prompt as structured knowledge. This combination forms the context that then gets passed into the LLM, which then generates a more relevant and grounded response. Now, the problem with that approach is, how do we deal with huge amounts of information or information that is changing constantly? Feeding everything into a prompt doesn't scale, and keeping it all up to date manually isn't really scalable. So we need a smarter way to keep LLMs informed without overwhelming them or us. The key idea here is smart context augmentation. Instead of dumping entire documents into the prompt, we provide the model just with the pieces of information that are required to solve the current task, like answering the current questions. For example, we can take some document sources like PDFs, Word, docs, or any type, and break them up into smaller chunks of information, like individual pages or sections. And then, when someone asks a question, we only pull in the bits that actually matter. In this example, maybe page 3 from one file and page 2 from another. Those chunks go into the knowledge part of the prompt, and that's what gets passed to the LLM. The benefits of that approach are that it's way more efficient than just pasting entire documents into your prompt. You're only including what's actually needed, which allows you to work with much larger data sources. It also tends to give better quality responses because the model's not distracted or overwhelmed by irrelevant information. And best of all, it plays nicely with existing search tools, so you don't have to reinvent the wheel. On the downside, this process can get complicated quickly, especially as you scale up and need to manage how chunks are created, retrieved, and inserted into the prompt. Which is why we have RAG. RAG stands for Retrieval-Augmented Generation, and it's a powerful design paradigm that helps us to manage this complexity. It gives us a structured way to store information, retrieve just what we need, and use that to generate accurate, up-to-date responses from a language model. Now let's look at the RAG process from a high level. Step 1. We store our documents in a searchable database. These can be PDFs, Word files, really anything that contains useful information. Step 2. When someone asks a question, the system retrieves only the most relevant information parts, or chunks, from that database. And finally, step 3, the LLM uses that retrieved information combined with its own reasoning abilities to generate a well-grounded response. So instead of guessing or hallucinating, the model stays connected to real, trusted knowledge sources in real time. More manageable chunks like individual paragraphs, sections, or pages. And then these chunks are prepped for fast and efficient search, usually by storing them in a database. And they are typically saved in 2 ways, as plain text and as numerical vector embeddings, which we'll talk more about in a moment. This is what sets the foundation for everything that follows in the RAG pipeline. Now, what are these embeddings? Embeddings really are just numeric representations of text. They turn each chunk of content into a series of numbers that capture its meaning, not just the exact words. These embeddings are usually generated by a dedicated embedding model, which works similarly to an LLM. For example, a sentence about dogs and one about wolves will end up with vectors that are close together because they are semantically related. In contrast, they'll be much farther away from sentences about apples and bananas, which again would cluster near each other. The big advantage of this numeric format is that we can now calculate distances between chunks. And that lets us pull out, say, the top 5 most relevant pieces for any given query. And that's really the heart of semantic search, which we'll get into next. But for now, just know that to store all these high-dimensional vectors and search through them quickly, we typically use a special kind of database called vector store or vector database. And that's what enables us to search not just by keywords, but by meaning. Now, once everything is stored and embedded, the next step is search. There are 2 main ways we can perform the search operation. First, there's the traditional search, keyword search. This works great if you're looking for exact words or phrases, like names, codes, or IDs. It works well when you know exactly what you're looking for, but of course it has limited vocabulary. On the right, we've got semantic search, and this is where things get really powerful. Instead of just matching words, it matches meaning. So if you search for employee benefits, it might surface results that talk about staff perks, even those exact words never appear. It understands what you're trying to say, not just what you typed. Now, instead of choosing between keyword search and semantic search, we can actually combine both, and that's what we call hybrid search. It gives us the best of both worlds, precise keyword matching and meaning-based retrieval. This approach is especially useful in real-world scenarios where queries can be messy, ambiguous, or a mix of structured and natural language. By combining both methods, we make our system more flexible, more accurate, and more reliable. So let's look a little deeper into how semantic search actually works. The first step is we convert the user's question, just like the documents, into an embedding. Next, we compare that vector to all the document embeddings in our vector store and find the ones that are closest in meaning. Finally, we return the top K chunks, that is, the most semantically relevant pieces of information to include in the prompt. And this process makes it possible to match intent even when the user's wording doesn't exactly match the source material. Once the basic RAG setup is working, you can start layering on more advanced techniques. First up, chat history context. Instead of treating each question in isolation, you include recent conversation history to give the model a better sense of continuity. Next, there's retrieval optimization. This means tuning how you rank, filter, or re-rank results, so you don't just pull in the top scoring chunks, but the most useful ones. Then there's iterative retrieval. In some cases, the system might retrieve once, generate a follow-up query, and then retrieve again, refining the answers step by step. And finally, business logic. You can plug in custom rules like prioritizing recent documents, avoiding certain sources entirely, or just showing information that the user has access to, all to align the behavior with real-world constraints. Now, these upgrades help make RAG more dynamic, reliable, and production ready. Of course, RAG isn't perfect. There are some real limitations to be aware of. First, RAG isn't great at doing math or comparing values, especially when numbers are pulled from different chunks. Second, it struggles with comprehensive analysis. If your query is something like find all x that meet condition y, RAG might not retrieve everything you need, or might miss edge cases entirely. It's also very data dependent, meaning the quality of the output heavily relies on the quality and structure of your input documents. And lastly, it can be really maintenance heavy. You'll need processes to manage data freshness, chunking strategies, embedding updates, and more. So while RAG is quite powerful, it's not a silver bullet. It shines best when used thoughtfully and with the right expectations. Now, let's flip the coin and look at what makes RAG stand out and so valuable. First, it's always up to date. You can update the knowledge base anytime, no need to retrain any AI model. It also scales effortlessly to massive knowledge bases. Whether you've got hundreds or millions of documents, retrieval keeps things really efficient. Another big plus, traceable answers. You know exactly where a piece of information came from, making it easier to verify and debug. And finally, it's surprisingly quick to set up. With the right tools, you can get a basic RAG system running in just a few hours and not weeks. To wrap it up, let's take a look at where RAG really shines in practice. First, customer service. RAG helps support agents or even chatbots pull in precise, up-to-date answers from internal docs, FAQs, and policies. It saves time and improves accuracy. Second, legal research. Lawyers and analysts can use RAG to sift through huge volumes of legal text and case files, surfacing only the most relevant excerpts without needing to scan everything manually. And third, knowledge management. Whether it's for internal wikis, product documentation, or compliance records, RAG helps teams surface what they need when they need it from massive content repositories. So, in short, whenever there's a lot of text and a need for fast, accurate answers, RAG fits right in. You can really choose any vector database that you like. Let's get started by going to the Pinecone website, pinecone.io, and click Sign Up. Here, enter your email address. This will register a new account. Of course, you can take an existing account if you have one. If you set up a new account, you should receive the activation code after a few seconds. Let's continue. And here we are. So this is important. You will now see your API key and you need to copy this key. So click copy and then close this window for now. What we will do next is to create our first index. This will be something like the database to store our documents in. So click create index. Let's give it a name, such as HR. And then switch over to select manual configuration. So this configuration must be mapped to the embedding model that you are going to use later. We will use Gemini, so that's why I will now update the configuration to match with the configuration of the Gemini model we are going to use. Make sure the vector type is dense. The dimension length should be 786, and the metric should be set to cosine. Scroll down, everything else can be left as it is, and click Create Index. Great, your first Pinecone vector store index has been created. So let's leave this page open and switch back to n8n. Now back in n8n, go over here and click Create Credential. From there, search for Pinecone. Select Pinecone API, click Continue, and here you can now paste your API key that you just copied into the clipboard. Hit Save, and that's it. Pinecone is now set up and it's connected to your n8n. You're all set. Let's move on. Workflow on a schedule, or if a different event triggers the updates of the documents. Next, let's define some variables. Because we will be pulling data from GitHub, we need to define the name of the repository and the owner of the repository. So I will define those as variables because we will need them 2 times. Select manual mapping and then add 3 fields. The repo owner, the repo name, and the document path. So in order to fill those out, go back to the GitHub repository, and you can copy the repo owner from here, put it in there, and likewise the repo name, copy it from here, and paste it in there. And finally, the path to the documents. Let's see where the documents are stored. So the documents are stored in this folder, Advanced Chatbot, and then Documents. So we can simply copy this path here and then put it back into this variable, into n8n. Click Execute Step, and you should see the variables here on the right side. Let's close this for now and actually connect GitHub. So let's add a GitHub node. Select List Files, and there we go. Make sure this is a public repository, but still you will need to have a GitHub account associated to your n8n profile here. So if you don't have a GitHub account connected to n8n yet, just select Create New Credential and then click Connect My Account. It will walk you through the steps of connecting your GitHub account to n8n. If you like, you can also create a new GitHub account if you don't want to share any existing data that you have. So let's close this for now. And then fill in the variables. Make sure the repository owner is set here by name. And then we pull over the repo owner. Also, let's set this by name and pull over the repository name. And then finally, the path to our documents. So let's run this and see if that works. Great. On the right side, you can see all the documents that are listed in this folder. So let's close this for now and add a second node. So this node will now actually download the files from the repository. Click Get File, and then select our Fields node and fill those variables here again. The owner and the name. For the file path, now we need to go back to our previous node where the path to the actual documents was stored. So let's pull that over from here. So n8n knows the path to each individual file that is listed in the folder. Make sure as binary property is marked on and all data is saved in a field called data. That's it. Let's execute this step. And now we have all our documents in here as binary files. Let's close this for now. And now let's add our Pinecone node. So click on Add Node. Search for the Pinecone Vector Store node, and then select Add Documents to Vector Store. Make sure you select the Pinecone account that you just created. If you click here from List, you should see the index that you just created before. So let's select the HR index. For the embedding batch size, we can leave this as standard. This is just how many documents are going to be stored here in a single batch. For now, there's nothing more we need to customize here. Let's close this. And before we run it, we need to add an embedding model. So click on this plus icon and search for Gemini. Again, you can use any model here, of course. I'm just using Gemini because this allows you to use your existing API key and also access the embedding model from Google here. But if you like to use any other model, that's of course possible as well. Just make sure it has the same configuration as the vector space that is set up in Pinecone. For the text embedding model, let's select the text embedding 004 and close this window. Next, we need to tell n8n how to process the incoming document, which includes the chunking logic and other things. So let's click this plus icon and select Default Data Loader. From here, let's select the type of data as binary because this is how our data is coming in. And as a mode, select Load Specific Data. From here, we want to select PDF because in this case, we just want our PDF file to be processed. If you had multiple file extensions, you could of course also select Split Pages in PDF. This will allow us to later on identify on which page of the PDF the actual information was stored. Next, we also want to add some metadata. Again, this will help us later on to cite sources and figure out where exactly our information came from. So click Add Property and then define one metadata field that is called Document ID. As a value, make sure in this case you select the name of the document that is currently being processed. As a second metadata property, we want to add the document URL. The document URL later on will allow us to actually click the source and open the corresponding document. So we need to pull in the HTML URL from here. Okay, great. So there's actually just one more step we need to do, which is to add the text splitter. This is to tell n8n how to chunk the incoming data and store it into Pinecone. So here we will use a recursive character splitter. The recursive character splitter allows us to define an overlap size. So every chunk has a little overlap to the previous and next chunk. So this is also something you would need to test out and figure out which of these values fit best for you. It could be that you select chunk sizes that are corresponding to the length of text on one page, or chunk sizes that are much smaller if you process more granular content. This is something you would need to optimize depending on your use case and by just interacting with the chatbot and see how it works. But by default, a chunk size of 1000 characters and a chunk overlap of 10%, which is 100 in this case, is a good starting point. Okay, let's close this window for now, and we're all set. This is actually the minimum setup we need to store our information as vector embeddings. So let's see how it works. Click Execute Workflow, and you can see the data is being loaded into Pinecone. If you click on the Gemini node here, you can actually also inspect the output. So you can see that we have the different responses here for the different chunks in our documents, and then each chunk has an array of 768 numbers. And as it turns out, these 768 numbers are the dimensions of our vector embedding. If you chose to have an embedding model with, let's say, 1000 embedding dimensions, then this length here would be 1000. So the more you have, basically, the more semantics can be stored in one embedded chunk. In this case, 768 is a good standard value, but modern embedding models often have even more than that. Let's quickly go back to Pinecone and see what actually happened. So if you still have this window open, you could see that now we see different chunks in here. And you can see that we stored the document ID, the document URL, which page this information came from, and of course, the actual text that was embedded here in vector form. So this is the minimal working setup. There's just one more thing we have to do in n8n to actually make it last. Because one problem that we have right now is once we execute this workflow multiple times, it will not actually update our existing vectors, but instead add new vectors as they are coming in, even if they are the same documents. So one easy fix around that is just to recreate your vector space every time from scratch. It might sound like a little overkill at the beginning, but in the end, it's one of the most straightforward solutions you can do, especially if you build your very first chatbot. So let's add this logic in here. Let's pull it over to the side a little bit and click on the little plus icon and add an HTTP request node. Okay, so in this HTTP request node, make sure you set the method to post and then paste your URL from the Pinecone vector store. Add vectors/delete. As an authentication, select predefined credential type. And as a credential, select Pinecone. Select your Pinecone account here. Then toggle on Send Query Parameters and choose Delete All. Set the value to true. Execute this step and go back to Pinecone. You should see that the record count now has been set back to 0, which means we deleted our data in Pinecone. You can see that we get this little error message here, which we shouldn't be worrying about because we just deleted everything in this particular index. So to ignore that in our workflow execution, go to Settings and on error, just say Continue. Close. close this for now. And now we have integrated an HTTP request that will delete our existing Pinecone vector store so that we can update it with fresh data. But in order for this to work, we need to add one more merge node over here, just to make sure that n8n actually passes just the data from GitHub over to the Pinecone vector store node and not the output from the HTTP request. So select merge here, and instead of append, let's say choose branch, and select data of specified input equals to 1. So with that, let's pull the merge node over here. Let's delete this connection and wire this HTTP request up with the merge node. We can press this little cleanup button over here so everything is nice and tidy. So now let's go ahead and rerun our entire workflow. Let's run it once. So we will again download all the data from GitHub. We will delete the existing data in the store, and then we will update the store with new data. So let's see if that worked. And there you can see we have 87 records in our store. Just to verify, let's go back again, click execute workflow. And as the workflow is now being executed, the existing data gets deleted. And let's check in Pinecone if we still have the same amount of records that we have now. Again, 87 records and not the double amount. So that's exactly what we want. Every time we load new data in, our store is being recreated from scratch to keep our data tidy in there. And this is the minimal setup we need in order to build our chatbot on top of that. Finally, let's rename this to Chatbot Data Ingestion and save our workflow. And that's it. I see you in the next video. Triggers this workflow, select when executed by another workflow. Just keep in mind that data ingestion right now runs every time we trigger it manually. The data retrieval workflow, however, should be triggered every time the chatbot is actually looking for internal information. And this is what we will later on add to our chatbot as a custom tool. Let's add a field here called query and make sure the type is set to string. Let's execute the step. You can see right now the query is null. For demo purposes, let's give this an actual value. Like for example, sick days. This will emulate a search query that the chatbot later on is giving to our retrieval flow. Let's hit save and close this window. Next, we'll add the Pinecone vector store node. Click Pinecone vector store and then get ranked documents from vector store. In here, make sure you select your Pinecone account that we just created. And as an operation mode, select get many, and then select your Pinecone index from this list. As a prompt, which in this case is the search query, we take the query that is coming in as the input of this workflow. The limit here specifies how many chunks should be retrieved. Again, there isn't really a single right answer to that. If you have very long chunks, you want a lower number here. On the other hand side, if your chunks are very short, you want a higher number. In the end, everything that is being retrieved here can potentially be added to the context of your chatbot. So for starters, let's set this limit to 5. But again, you can of course experiment with that. Let's make sure include metadata is turned on. Let's close this for now and add our embedding model. Now this is important that this is the same model that also embedded the data during the ingestion flow. So here we select embeddings from Google Gemini and choose the same model that we chose before. Let's close this and actually try out our retrieval. So you can see, given the query sick days, we now get a list of 5 document chunks in here. And each chunk comes with the actual page content that was embedded in that chunk, as well as the metadata for each chunk. And now this will allow us to actually pre-process this information and feed it back to our chatbot. And to do this, let's make sure we tidy everything up into a nice and clean data object. So select the Edit Fields node from here. And let's add the following fields. Of course, first of all, the content. That's one of the most important things we want to retrieve. Next, the file name. The file name later on will allow us to actually produce the sources. Along with the file name, we also want to have the URL. The URL will later on allow us to click on the source and actually open the corresponding document. And then finally, we want the page number. So the page number just helps us to locate exactly on the page where the information was stored. After we have this information, click Execute Step, and you can see that each item just has those 4 fields: content, file name, URL, and page. So let's close that and add an aggregate node, because we need a simple data structure to send later on to our LLM. So what we want to do is flatten the incoming data here and just add it to one data field. So select all item data into a single list and make sure to include all fields. Click Execute Step, and you can see instead of 5 different items, we now have one single item where each node is one chunk with the corresponding metadata. So let's go ahead and finally store that in a form that can be easily transferred to the LLM and put into its context when generating the answers later on. And the way we do this is by defining another edit fields node and just saying that the response. The way we do this is that we just define a single output variable called response, and in this response variable we just take the information from the previous node, and in this variable we just pull in information from the previous node and make sure that this is formatted as a simple string. So now as we execute this, you can see the result of this entire workflow is just one single text string that is then being sent back to the LLM. So we get a simple search query in, we get the ranked chunks back from the Pinecone vector store, we add metadata. If we filter this data, like for example, just showing chunks that are in the same permission group as the user who asked for that information, but this is the minimal setup here we need, and in the end we have one object, one big text field that we send back to the LLM that contains all the information about the retrieved chunks, as well as the source information like the document ID, the document URL, and the page number where this information was found. So next step, let's rename this workflow to something like Chatbot Data Retrieval and save this workflow so we can then plug it into our chatbot in the next step. So I look forward to seeing you in the next video. For now, we can just close this field and add our AI agent node. Make sure that this is connected to the chat trigger, and then let's add a system prompt to it. Again, the system prompt will tell the agent basically how to behave, but also that it should call a tool in order to retrieve knowledge. So let's go back to our GitHub repository, and in this repository under advanced chatbots you will find the system prompt. Now let's take a look at this briefly. The system prompt is actually really similar to the system prompt that we had before. There are just 3 key differences. The first difference is that this system prompt tells the agent to get information that is found in the getHR policy tool. So this means it's not looking for information inside the prompt, inside the FAQ, but it needs to call a tool, which is called getHR policy, in order to retrieve knowledge that it will then use to answer the question. The second modification is that we added this line over here. If the user asks a very broad question, try to narrow it down first so you can provide more compact answers. Why are we doing this? Well, because one of the problems of our RAG architecture and RAG architectures in generally is that those open-ended questions can't really be answered. For example, if a user asks for all company benefits, then this can't really be answered unless there's some text in the source documents that lists all those benefits in one place. But otherwise, because we always limit the amount of chunks that we retrieve, we can't really be certain. So that's why whenever the user asks one of those very broad questions, we want the chatbot to ask back and actually narrow that down so we can then retrieve information that is actually correct and relevant to that question. And then finally, we also added citations. So citations basically means that when the chatbot generates the answers based from the retrieved chunks, it should also give the citation or show the citation where this information comes from as a footnote here. And the way we do this in this case is just by providing this as instructions here in the prompt and then giving an example of how the citation should look like. In this case, the footnote followed by the document name and then the URL to that document. So that's the system prompt we're going to use. So let's copy everything from here and go back to n8n and then paste that into the system message. All right, let's close this AI agent node for now and let's add a chat model. Important note here, at this stage, you can really use any model. I will be using Gemini again, but just because we have the API key for that. There isn't really now any connection between the model that is holding the conversation with the user and the model that we use for the embedding. Because remember, the whole retrieval logic is now outsourced to a separate workflow. What we just do here is to send a keyword to this workflow, and then this workflow will retrieve all the relevant information from our vector store. So you can really pick any model that you like from here. I will go with Gemini 2.5 Pro because it's one of the best models here. Make sure that you select Options, Sampling Temperature, and set that back to 0. I don't know why n8n has a high sampling temperature here out of the box. So let's close this for now and add a memory to our agent. Again, let's just add a simple memory here. Adjust the context window length to a message to something like 20. Again, this is just the number of messages or past interactions that the bot can remember as part of an existing conversation. Again, feel free to adjust that to your preference. And finally, tool use. Now, this is the most important piece because as a tool, we want to define the workflow that we just set up. So let's choose Call n8n Workflow Tool from here. And first, let's give this tool a little description. In this case, we are going to be explicit about the name. We will call it Get HR Policy. And then add a little description like this tool will search the HR knowledge base. So this description essentially tells our chatbot that this is the tool to get information from the HR knowledge base. To keep things tidy, let's also assign this here as a name for this node. Now let's pick the workflow that we are using for this. Search for retrieval to pick the chatbot data retrieval workflow that we just defined. You will see that the workflow inputs are listed here automatically. We need to click this little AI icon to tell n8n that this query parameter should be filled in automatically by our chat model. So that's the setup we need over here, and let's close this one for now. And basically, that's it. That's the minimal setup we need to build an AI agent that is now able to pull documents from our internal knowledge base. So let's try it out. Click Open Chat, and let's greet this agent with a little hi. So you can see the response over here. Hello, I'm your HR assistant. How can I help you with HR policies today? And the interesting thing is now that you can see that this agent actually did not use any tool. The agent just used the Gemini chat model in order to generate the response. But let's see what happens if we ask it about something that it needs to search in our HR policy documents. So for example, we could ask it something like, where do I apply for vacation? And you can now see that it used the knowledge tool here in order to get that information. It's also shown in the traces of the AI agent. So let's take a look at what happened here. So if you click on this Get HR Policies tool, you'll see that the search query in this case was vacation application. And this search query was defined by our chat model. And if you click on output, you can see the chunks of information that were being retrieved for this particular search query. Now, Gemini, in this case our chat model, used this information to put it into the context of the current conversation and generate the final answer from that, which in this case is you can apply for vacation by following these steps. And you can see that in the end we got a citation of where this information came from. Now this is great because it shows us that our chatbot is working as expected. Now let's ask it about something that is actually not stored in our knowledge database. Like for example, how can I get a MacBook? You can see that the agent is now going back to the Get HR Policy tool again and sending the query how to get a MacBook. But the thing is, there isn't really a term MacBook stored anywhere in our documents. So what happens is that our search just returns the closest chunks to that. And very close chunks to that are things that, for example, contain personal laptops because it's semantically really close to a MacBook. So that means this is the information that our chatbot now has in order to generate the answer from. And in this case, it answered something like this. Based on the IT policies, here's the information regarding the company equipment, provides the necessary computer. For special equipment, you should talk to IT, and personal laptops are generally not allowed for work. Now, you might get a slightly different response, but the key insight here is that our chatbot was able to answer that question, even though the specific keyword MacBook was not in our original knowledge source. So this is why these agents are so powerful, because they allow to have these natural sounding interactions without actually being restricted to doing a plain keyword search. We still search for a keyword, but the results that we get are even richer than that. That's what we call a semantic search. Now that we confirmed our bot is working, let's give this a name. Let's, for example, call it Advanced Chatbot, and try this chatbot out in the real world. Hosting options here, I'm choosing the hosted chat option here. And if you like, you can customize your chat with the title, subtitle, the custom chat styling, and everything like that. But for now, let's just try it out. So let's click the chat URL over here to copy it to the clipboard, open a new browser window, and just paste the URL in here. And if you see an error message like that, this happens typically when your chatbot is not live yet. So let's go back to n8n. And in order to make this chatbot actually live, we need to toggle it on. So activate the workflow by toggling on this little button here. You get this information that your bot is now active. So click on OK and back to our URL. If you refresh this, you will see that our chatbot is actually working. So let's type a question. Let's, for example, ask it again about the vacation policies. So you can see that the chatbot is now generating the answer. And of course, sometimes it takes a little longer because, especially if you have very open questions, it will either go and fetch a lot of information, or it will ask a follow-up question like this one. Because this was a pretty broad information, it asks us whether we are looking for vacation time or for carryover of unused vacation or anything else. In this case, let's just say the first. And this will also help us to confirm that our chatbot actually keeps track of the previous conversation, because otherwise it wouldn't know what the first means. But now it goes back to our database and searches for the vacation time accrual. And this is the information that it shows to us. So you can see we get this nice list here. Full-time employees earn 15 vacation days per year. And this is equivalent to 1.25 days per month. And we also have the sources for that information here. So you can see that this is coming from the leave and time off policies and the employee benefits and perks. If we wanted, we could also adjust our system prompt to also show the page where this is stored. Currently, I just have this for debugging purposes stored, but if you want, you could of course also show that here to the user. Just add it to the system prompt as an example that you want the page shown in here. Now let's click on the PDF, and it should open the PDF document in its original storage location. In this case, that's the GitHub repository, and you can see document 7 here, the leave time and time off policy. So the employee could now go back and verify the information from the chatbot, or just read it in more detail. So going back to our chat, you can now try it out and ask it a couple of different questions. Like, for example, what benefits do I get? And you can see that this takes a little while to generate. n8n currently out of the box does not support chat streaming messages, as you are familiar with from ChatGPT, for example. So if you're more interested in that, we'll talk about this in the next chapter, where we talk about the optimization and performance improvements of a chatbot like this. But in general, it's working as expected, and feel free to ask the chatbot a couple of questions and see how good it is working for you. And again, congratulations for launching your very own chatbot with a powerful RAG architecture under the hood that you can flexibly customize according to your needs. Using no-code building blocks, we use prompt engineering to guide how the LLM responds. And we added memory buffer so the chatbot could remember previous messages and hold context across a conversation. Then we integrated document retrieval using RAG. allowing the bot to pull in real answers from our internal docs. And importantly, we used our own documentation as the knowledge base, so the chatbot's answers are grounded in what we actually do. Now, let's talk about the strengths. First off, it was super fast to build thanks to n8n. The LLM can also easily be swapped, which gives us flexibility to upgrade or change providers. We didn't need any external dev support. This was built entirely with no-code tools. And it's designed for easy expansion. New workflows, new data sources, new logic. It's all modular. And best of all, this can already be used to reduce the workload on the support team in HR. So what's the real value delivered here? Chatbots like the ones you just built give us fast answers grounded in real documents. It's significantly reducing the risk of hallucinations by pointing to actual internal knowledge sources. And it's easy to extend. We can keep adding workflows and automations on top of it without breaking what's already working. Just as important, here's what we didn't build yet. We don't have user authentication or session management. Also, there's no polished chat UI or widget integration. This is backend only for now. We're skipping caching, error handling, and retries to keep things simple. Also, there's no security gateway and no monitoring or analytics built in. We kept the scope tight to move fast, but these are gaps we'll want to close as we move forward toward production. So what's next? First, we would test and validate demand, make sure people actually want to use this. For this, we'd want to optimize the UI a bit or plug it into existing tools where people already work. Then we should define and handle edge cases. What happens when a query fails or returns something unexpected? Next, we'd automate document updates so the knowledge base stays fresh. And finally, we'd define a development roadmap so we're not just building features, but doing it in the right order. With a solid foundation like that, it's time to refine, scale, and ship. So let's explore how to tackle some of the most critical optimizations. We have different needs, so it's important to meet your users where they are. The good news is, with tools like n8n, you have that flexibility. You can integrate across platforms, choose your own front end, or embed directly into the tools your team is already using. Let's take a look at some options. First option, just use n8n's built-in front end. That's just what we did in the demo. It's the fastest way to test your chatbot backend and great for early prototyping. n8n offers either a hosted option for your chatbot or a simple integration through an HTML widget. But the customization options here are limited. Talking about customization, the default look and feel that you get out of the box from n8n might not best-case scenario. Mostly text, clean layouts, and consistent formatting. In reality, however, you'll rarely find documents like these. Things you'll encounter instead are scanned PDFs with bad OCR, multi-column layouts, complex headers or tables, and illustrations and diagrams. Remember, our vector embeddings that are the backbone of our RAG architecture basically turn text into numbers that contain semantic meaning. But if the text isn't clean, the embeddings won't be clean either. So in short, garbage in, garbage out. If your documents are a mess, your chatbot will sound like a mess too. So we need to invest upfront in cleaning things up. A few strategies for that. The first strategy is all about pre-processing. If you use OCR, make sure it actually worked by verifying the outputs. Take samples or look at the documents manually initially. Flatten pages that have weird layouts like columns or mixed formats. Strip out headers and footers before embedding and process any images separately. Basically, clean your inputs before you feed them into the model. It makes a huge difference. Next, add metadata, lots of it. We already store the file name and page number, but you can go even further and store sections, corresponding headings, or other references that allow us to interpret the information even better. When the chatbot responds, make sure to retrieve that metadata as well, so both the chatbot and the users know where the answer came from. That traceability builds trust and makes debugging way easier. Strategy 3. Don't boil the ocean. Start with one clean, business-critical domain, like HR policies or customer service. Test deeply for accuracy, tone, and traceability. Get that one domain right, and then expand from there. Scaling quality is a lot easier than fixing chaos at scale. Strategy 4. Track document freshness and versioning. Add timestamps to every version. Prefer the latest one during retrieval. And if you can, automatically expire stale chunks or just rebuild the vector store every time based on the latest available information. Keeping things fresh is key for accuracy and trust. Now, as our chatbot evolves, so should your RAG system. We've built a foundation, but of course, there are many things to improve from here. Concretely, there are 4 main areas to focus on. First, optimized embeddings. This means choosing the right embedding model or tuning it to improve how your content is represented. Then, advanced retrieval. For example, filtering by metadata, like who's allowed to see which documents, content type, or document recency to reduce noise and surface better candidates. Third, ranking. Instead of relying on raw similarity, you can re-rank the top results based on custom scoring, like how relevant, trusted, or recent they are. And finally, search query optimization. You can improve results just by rewriting the search query, expanding it with related terms, adding context, or tailoring it to the user's intent. These steps don't require a different architecture, but they can massively improve quality and reliability. And finally, if your content is chaotic, try adding structure. One way is to use a knowledge graph to anchor your retrieval in clearly defined concepts. This lets you convert unstructured documents into linked entities and relationships. For example, when someone asks about a leave, a knowledge graph-based RAG system would know from this graph that there are different types, sick leave and vacation leave, and that sick leaves require a medical certificate. It could also trace the source directly to the right policy document. Yes, it makes more effort to build this upfront, but the payoff is better retrieval precision and more explainable results. So what's the takeaway? Handle one domain at a time. Clean your documents, simplify layouts, enrich metadata, and structure what you can. Also, filter out stale or low confidence content. If the source is sketchy, the answer will be too. A clean pipeline makes for a smarter, more trustworthy chatbot, which you can expand and improve as you go. That leaked internal information, provided wrong responses, or could be tricked into emulating a different persona. We don't want this happen to you, so let's take a look at some key security and scaling paradigms. First, security. There are 3 key areas to secure. The first is to control what gets sent to the LLM. Filter or sanitize inputs in n8n. Strip away unsafe or irrelevant content. One way to do this in n8n is to implement a security gateway that sits between the chat input and your chat LLM. This gateway ensures that the chatbot only sees user messages that are not harmful or manipulative, including filtering out prompt injections. There are multiple ways to do this, but one straightforward solution is just to use another LLM to classify the incoming messages by risk. If an incoming message is too risky, the text will simply be replaced with a redacted string value in n8n. Second, prevent data leakage. The easiest way to do this is to allow users to query only the data they should access. This typically gets achieved by passing the user access group as a metadata information to the retrieval node along the query, and so using that as a filter when you retrieve the chunks. But even after retrieval, you might want to clean the data, removing fields like personal information or internal fields before the LLM even sees it. Third, protect your infrastructure. Use rate limits and monitor traffic to prevent abuse. If your LLM provider supports it, set budgets or token limits to avoid extremely high costs. Once your bot is secure, you need to make it scalable. Caching is a huge win. Store answers to frequent questions using simple input hashes, especially when you show suggested questions to users. You don't really want to generate them every time by the LLM, but just show them a cached response instead. This saves tokens and keeps latency low. But infrastructure matters too. n8n Cloud is great for testing and offers a low barrier to set up. It's also ideal for early development environments or internal applications. But if you need more control over your data and workflow performance, the n8n on-prem version is worth a look, ideal for larger enterprises or regulated industries. Talking about performance, there are quite a few levers you can pull to make your chatbot even faster. First, make sure that you choose a fast yet capable chat model like Gemini Flash or GPT-4o. This allows you to get back to your users faster without compromising too much on context understanding. Second, minimize retrieval latency. That means making sure you don't overload your retrieval workflow. Keep it basic and don't add too many separate workflow steps in here. Each step will cost some time. Third, use a fast vector store. Compare different providers and see how fast they come back to you after sending a query to their API. And last, cached responses wherever possible. We talked about that before in regards to cost. But of course, caching also reduces the time. If a user asks a similar question, you shouldn't hit the LLM again with it. Instead, use a semantic or recently used cache to instantly return previous answers. These 4 strategies alone can cut down your end-to-end latency significantly while keeping your system stable under load. Monitoring in place from day one. First, your documents will change. There will be updates that will probably make things that worked before not work anymore. Also, if the document can't find the right content, it won't tell you. It'll just fall back to the default response or, worst case, hallucinate wrong answers. Token usage and cost might also silently grow. And user evolve too. They might ask new types of questions you didn't anticipate. So what do we actually want to track? At a high level, we care about usage and quality. On the usage side, track volume, peak usage, and popular questions or topics. On the quality side, look at fallback rates, thumbs up or thumbs down feedback, and retrieval metrics. Are we surfacing the right chunks or not? And of course, answer accuracy. The key to tracking this is logging the right data. You'll want to log each user query, the context it came with, and ideally a session ID and timestamp. Also, log what content was retrieved, from which document, version, and page. And of course, log the final LLM response and whether it was a fallback. If you're using n8n, it already gives you plenty of tools to do this. You can use webhooks to log data to the cloud, or the save file nodes on local deployments. Use the built-in execution log to capture workflow runs, and forward logs to tools like Grafana or Datadog for visualization. And you can even trigger alerts for key metrics like fallback rates. Start simple and then scale up. Especially at the beginning, you want to review previous chats manually, or at least a sample of them to get a feeling for how things are working. Once you've got the logs, make them useful. Create reports that categorize queries by topic, track how topics trend over time, and see how often issues get resolved. A visual overview can help you find gaps or failure patterns. You can also layer in thumbs up or down data to get a sense of quality trends. Your content isn't static, so your bot shouldn't be either. Reindex documents on a schedule or trigger uploads when content changes. Add version tags to content chunks if needed. And with n8n, you can automate the upload workflow to ensure freshness without manual effort. The real secret to long-term chatbot performance is a strong feedback loop. Monitor usage and quality, analyze logs and feedback, update content or the logic, test, then deploy, and repeat. It's this continuous iteration that will keep your system accurate, efficient, and relevant.